Yeah, welcome class. We are actually in the part 3 part of what? Electric force. I'm giving you this bit by bit so that what you can assimilate the first one before moving to the next one. Some students just only understand the word formula, and whenever physics is always funny, they shoot the question. Don't expect them to ask you a direct question. So when they shoot the question, students find it what they will now be complaining that this is very difficult. So that's why I'm taking my time to break it down. Please, I want you to take alongside with your textbook so that you can actually understand those concepts better and you can ask me questions. Now, Coulomb's law, what does Coulomb's law state? I've actually break Coulomb's law down at the first part. I said that what? F is what? The first product law. You have what? F is what? Directly proportional to Q1 and Q2. And I said that this F is also inversely proportional to what? The product of the what? The distance between the square distance between what? The two charges. Now we are going to apply your variation, which is what? Your joint variation. We are going to combine them together. Now we have that what? F is what? Combine them now what? Q1, Q2 over what? R squared. So therefore we can say that what? Our F, remove this and put your constant of proportionality equals to what? KQ1, Q2 over what? R squared. So therefore I can state that what? My Coulomb's law state that the force of attraction and repulsion is directly proportional to the product of the two charges Q1 and Q2, and is a conjunction. I'm now combining them together, and inversely proportional to the what? To the square of the distance between the two charges. As you can see here, that is what I've just done. I apply what they call joint variation in mathematics. So this K here, it's a constant. This K here, it's a constant. Your force constant, and this constant is actually identified as what? K equals to what? 1 all over 4 pi epsilon naught. 1 all over 4 pi epsilon naught. Please note 1 over 4 pi epsilon naught, and it's a constant. And this epsilon naught is called permittivity. Permittivity. Sorry, of what? Free space. I'm going to explain that. Permittivity of free space. So mathematically, when they combine everything together, your K becomes what? K equals to what? When they combine everything together with the permittivity of free space and the what? 4 pi epsilon naught, they combine everything, your K becomes what? 8 point, please note, 8.99 times what? 10 raised to power what? 9. Times 10 raised to power 9. I'm now going to take you back to your what? Dimension. I don't like students just going rushing. So for us to get the unit, how do we get the unit? We know that what? Our Q is, what's the unit for Q? Is what? Charge, coulombs. What's the unit for force? We have it as what? Newton. What's the unit for distance? We have it as what? Meter. So let's put this there. We have F equals to what? KQ1, Q2 over what? R squared. Let's put the unit. Newton equals to what? We don't know K. So that will be what? Coulombs times coulombs over what? R squared. So we have it as what? Newton equals to what? Kc square, Coulomb square, over what? R square. Make your K the subject of formula. Your K becomes what? Newton R, that will be meter square, sorry. Meter square. I said R square. Meter square. So that will be what? Newton meter square. Meter square over what? Coulomb square. So you have it as what? Your K is equal to what? Newton meter square C minus 2. Are you seeing it? So that's what? Newton meter square C minus 2. So you need to note this.
That is the constant that we're going to be using when the permittivity, everything is actually put inside, the values, the magnitude. When they are put inside, this is your constant. So whenever you are given any question, you are going to what? Use this constant. This K is constant, so you need to know it. And in some textbooks they might tell you that is what? 9.0 times 10 raised to power what? 9 Newton meter square per coulomb square. It's the same thing. They just what? Approximate. So they are the same. So you should understand this. As you can see, look at it. The constant in a free space. What happens? What can you tell me about this? At the next class, we are going to be looking at you identifying the difference between this constant and the one I'm going to introduce to you very soon.
So now let us look at what? Let us look at some questions under this. Some questions under this. Let's take one question. So then I explain what permittivity really means. Let's take one question. So they said an electron is at a distance. So as you can see in this question, we have that what an electron is at a distance of 5.0 times 10 to the power minus 11 meters away from the center of a proton. So we all know from our chemistry knowledge that what? Electrons are negatively charged and protons are what? Positively charged.
Calculate the electrostatic force. You know what is the electrostatic force that will be occurring? Is the force of what? Attraction. Because of what? They are what? Unlike charges. That one thing you should know. Their force of attraction. They are unlike charges. Unlike charges, we what? We what? Attract. So now we have it that what? They said we should calculate the force of the electrostatic force, which is what? Your KQ1 or Q2 over what? R squared, as you can see. Now, before you start writing, you can write down your formula, also your parameters. So we are looking for the force of attraction. We don't know. We have our K as what? 9.0 times 10 raised to the power 9 Newtons meter square per coulomb square. This is what? This is really required in physics. If you want to make your physics interesting and easy. So we have the what? The electron charge, which is Q, is what? Now this negative that you are saying from this question does not mean that what? You have to put minus. It's just showing the charge. So you just put what? 1.6 times 10 raised to the power minus 19. It doesn't mean that you should now put minus. No, it's just showing that what? It's what? Negatively charged. And QP, which is what? Charge for proton, is what? 1.6 times 10 raised to the power what? Minus 19 coulombs. Some people might be asking me, why are they the same? Now, from your pen, we have that what? PEN. I wouldn't go into. You know that your proton, the mass of proton, the charge of proton and the electron must be what? Equal. They are equal to each other. So from there you understand that. So we have it as what? The distance given to us R equals to what? 5.0 times 10 raised to the power minus 11 meters. So therefore we have the force of attraction, please. Let's make everything easy. 9.0 times 10 raised to the power 9 times what is your force charge? 1.6 times 10 raised to the power minus 19 times 1.6 times 10 raised to the power minus 19 over what is your R? You have 5.0 times 10 raised to the power what? Minus 11. So your FA equals to what? 9. I want you to punch the calculator. You can use standard form, but I want you to punch your calculator. You can use standard form by saying 9.0 times 1.6 times 1.6 times 10